Hi, my name is Miss Townsend and I love math. Welcome to Math with Townsend. In this video, I'm going to do an example of a quotient rule derivative question. And this is coming from the worksheet titled Sauron, question 4F. And here is the function that we're going to take the derivative of. So we can see that this requires us to use the quotient rule because I have a denominator, which is a function, which is more complicated than a simple monomial. So let's use the quotient rule. So we need to be taking the derivative of the top and the bottom in the quotient rule. Let's go ahead and do that. So I need to take, so the rule says the derivative of the top times the bottom minus derivative of the bottom times the top divided by the bottom squared. So let's take the derivative of the top function. There's the top function. So the derivative of the top. So what I have in the top there is a power of a function. So the derivative of that would be 2 times the bracket, and then that would be exponent 1. Obviously, I don't need to write it, but I did just to show the process. And now I still have to continue taking the derivative because inside that bracket is a function, and the derivative of that is 2. So there's the derivative of the top times the bottom. So just the bottom function, do not change it, minus. Now I need to take the derivative of the bottom function. So looking at the bottom function, I have another power of a function rule to use. So 3 times the bracket, and then subtract 1 from the exponent. And looking inside that bracket, I need to take the derivative. Well, the derivative is just 1, so again, I don't need to write it, but I'm doing it just to show all the process. And then I need to multiply that by the top. And then all of this is divided by the bottom function, which is x minus 2 to the exponent 3 squared. So derivative of the top times the bottom minus derivative of the bottom times the top, and then divided by the bottom squared. So what are we going to do here to clean this up? Well, obviously in the denominator, I've got the exponent law to apply that says that when I have an exponent that has a higher exponent, I multiply them together. So the bottom becomes x minus 2 to the exponent 6. And now looking at the numerator, so in this first term, so this whole first term right here, I have a multiplication by 2, and then a bracket, a multiplication by 2, and then a bracket. And I don't want to expand those brackets if I don't have to. So I'm going to do 2 times 2 is 4. And then I would have 2x minus 1 to the exponent 1, and x minus 2 to the exponent 3. In this second part, right here, I have 3 times a bracket times 1 times a bracket. So again, I don't want to break into those brackets. So I'm just going to multiply the 3 times 1. So I would get minus 3, and then x minus 2 squared, 2x minus 1 squared. So that's the first step. So now I'm going to look for common elements that I can common factor in the numerator. So if I look at just the coefficient pieces, there's nothing common between 4 and 3. But obviously this bracket is common, so I'll factor 1 of those. And the other bracket is also common, so this bracket is common, and I can factor 2 of those. So those are my common elements, and then let's see what's left over. So in the first term, I need the 4. I don't have that yet. I have this bracket fully factored out. This originally had x minus 2 cubed. There were 3 of those brackets, and I only factored 2, so I need another one of those. And then I can move on to the second bracket, or sorry, the second part of the numerator. I need the minus 3 because I didn't factor any of it. X minus 2 squared is fully factored right here. 2x minus 1 squared, I only factored one of those, so I need another one right here. And then we can't stop writing the denominator because otherwise we can't use that equals sign. And so one thing you'll notice is I know I have a bracket to clean up, but before I even look at that, because I common factored that x minus 2 squared, I can simplify that because I have x minus 2 to the 6 in the denominator. So effectively what I'm going to do is exactly what I would do is if I had a squared over a to the 6, how would I simplify that? Well, the long process would be to apply the exponent laws, saying if you're dividing the same base, subtract the exponents. So I would have a to the 2 minus 6. So that would be a to the negative 4. But we would write that as 1 over a to the 4. So the faster version of that is that these two versions will cancel out 2 of the 6 that are in the denominator. So I'll end up with 4 of them in the denominator. That's just a faster logical way to do it. So I'm going to still have this 2x minus 1. I'll get to that bracket in a second. The denominator is now x minus 2 to the 4. Again, because these two versions of x minus 2 canceled 2 out of the 6 that are in the denominator. So I'm left with 4 there. So now let's look at what's happening in this squared bracket. So I need to expand, collect like terms, and see what else I can do. So I have 4x minus 8 minus 6x plus 3. And if I collect like terms, let's see what we get. So 2x minus 1. This gives me negative 2x minus 5 over x minus 2 to the 4. And, you know, you could argue that that's simplified, but I think you'd be wrong because we do not like having negative values in the front of a binomial bracket. We just don't like it. Boo. And so I'm going to factor negative 1 out of the bracket. So in fact, I mean, there's definitely a negative sign in common anyway, but even if this was plus 5, I would still want to factor that out. So from that bracket, I'm going to factor negative 1, and I'll sort of show this in 2 steps. So that negative 1 factored out is right there, and that would leave me with 2x plus 5. And then that negative 1 should really be written in the front like this. You just don't leave it in the middle like that because it's the monomial part of that numerator. So you want it before the brackets. So this is the derivative in fully simplified form. Thanks for watching.